Today, lesson 11B, day number 5 of applications of systems of equations. This is the last day of the 5 days of lessons involving word problems, where we either set up a multi-step equation or a system of equations to solve. Today's problems deal around the idea of finding people's age. So let's just go ahead and get started. Number 1, Sara is 21 years older than Laura. In 6 years, Sara will be twice as old as Laura. How old are they now? Well, when we're trying to deal with a problem like this, we of course could use some sort of guess and check, but depending on the numbers and depending on how they compare to each other, that could take a while to do it. So a much faster way of dealing with these would be by setting up a system of equations. And as usual, I am defining my variables. I will use S for Sara's age and L for Laura's age. And I'm going to come up with 2 equations for my system. One that I refer to as a now equation that basically compares their ages now to each other. And then a past or future equation, depending on whether we're talking about in the past or in the future. So for the now equation, it would look like this. S equals L plus 21. Because I know that Sara is 21 years older than Laura, so to make sure that they are equal, I would have to add 21 onto Laura's age so that they would be equal to each other. And if you think about it, that's kind of like some of those problems that we've dealt with in the past. Now, the past or future equation. Well, the second sentence says, in 6 years. So 6 years from now, to find all of your ages, you would simply have to add 6 onto your current age. And so we're going to use that kind of thinking to start this one off. So in 6 years, Sara will be 6 years older. In 6 years, Laura will also be 6 years older. But it says in 6 years, Sara will be twice as old as Laura. So to maintain the equality there, I have to multiply Laura's age by 2. So let's take a look at that system. The first equation is S equals L plus 21, because to make sure that they have equal ages, we have to add 21 onto Laura's. In 6 years, that's where the S plus 6 and L plus 6 comes from. But to make sure that they are equal to each other, we have to multiply Laura's age by 2, because Sara is the one who's twice as old. Now from here, you can either use elimination. If you're going to do that, you'd have to put them both in standard form, or you could use substitution. And it doesn't matter to me, but I'm going to help you through this one. And I typically use substitution for one like this because we're already solved for a variable. So we know that S is equal to L plus 21. So I'm going to take L plus 21 right here, and I substituted that in for S right there. That's how I got L plus 21 plus 6 equals 2 times the quantity L plus 6. Now I'm going to let you take it from there. So we take what we have here, use the distributive property, combine like terms, solve for L, and I cut out some steps there, but Laura is 15, as you can see. To find out how old Sara is, I will take the simplest place to substitute that back into, and that's that original first equation, the now equation. And when I do that, we can see that Laura is 15 and Sara is 36. Now, a quick check. The problem states that Sara is 21 years older than Laura. And as you can see right here, that is true. Sara is 21 years older than Laura. And then the second one says in 6 years. So Laura in 6 years, this is how old she is now, that would be 21. Sara in 6 years would be 42. So you can see in 6 years, Sara is twice as old as Laura is. So we know everything has to work there. All right, any questions about number 1? All right, everybody try number 2 all the way through, please. Here. Defining my variables here, W for Will, B for Brooke. The now equation, it says Will is 13 years older than Brooke, so you would have to add 13 onto Brooke's age to make them equal to each other. Past or future equation, it says in 9 years, So we have to add 9 onto both of their ages to figure out how old they would be in 9 years. Will be twice as old, so we would have to multiply Brooke's age by 2 to make them equal to each other in 9 years. From there, either substitution or elimination. I'm using substitution one more time. Combine like terms and distributive property, and we get Brooke is 4 years old. Any questions about number 2? All right, let's continue on here. Number 3. Number 3 states that Stan is 2/3 as old as Adam. Now, reality is, other than the fraction portion, this problem is just like number 1 and number 2. Anybody have any idea what the now equation should look like then? Ivan?
Well, for my variables, I put S equals A plus 2/3.
Well, it doesn't say he's 2/3 of a year older. It says he's 2/3 as old. Mason?
Would be S equals 2/3 A.
There you go. Yeah, it doesn't say 2/3 year older. It says 2/3 as old. So that would be my now equation. Now my past or future, it says in 7 years, Stan will be 3/4 as old as Adam. So what will that equation look like?
S plus 7 equals...
Did you say 2? Well, it doesn't say twice as old. It says Stan will be 3/4 as old. Okay, there we go. There we go. All right, I'll let you finish it from there. Obviously, because of the fact that we have fractions involved here, we have to pay a little more attention to what we're doing there. But a lot of the things that we've talked about this year, ways of taking equations and getting rid of fractions, all of those things still apply because we have equations here. So we have our system. I, once again, am going to use substitution. So I substituted this in for S right there. That's how I got what I have right here. I'm going to use the distributive property, and it's at this point that you should use the multiplication property of equality, in my opinion, and multiply everything by 12 to get rid of the all the fractions in there. You are way less likely to make a mistake, and you have to admit that this looks much easier to deal with than the mess that we had right there. And so at this point, we solve for A. We get A equals 21, so that means Adam is 21. And go back to S equals 2/3 A, and 2/3 times 21 is 14. So Stan is 14, and Adam is 21. All right, so now let's go to number 4. And I want everybody to read number 4. And what's different about number 4 compared to perhaps number 1, 2, and 3? Aaron? There we go. A past equation. But reality is the setup is the same idea, except we have to think about how we're going to deal with that 5 years ago. So I'm using M for Miriam and R for Ron. My now equation, of course, is M equals R plus 4. So what is my past equation going to look like in this one? Yes? Yeah, think about this. To find all of your ages 5 years ago, you have to subtract 5 from your age. So that's how we start the past equation. 5 years ago, we can find Miriam's age. 5 years ago, we can find Ron's age. And I think you know what to do from there. So I will let you take it from there and finish it. That is correct. I'm going to use the substitution method, then combine like terms and distributive property like I've done in every single one. Solve for R, we get R equals 9. And then substitute that back in, and we see that Miriam is 13, as you said. So Ron is 9, Miriam is 13. All right. Number 5, you do it all the way through, please. As all of you are working through this, what's that now equation look like? because we had to pay attention to something in this one. What does the now equation look like? What's that? Anybody have something other than a plus 24 equals d, George?
I got a plus b minus 24.
Okay, are those two things equivalent to each other?
Yes.
Yeah, sure they are. A plus 24 equals d is the same thing as a equals d minus 24. If you don't believe me, take a minus or equals d minus 24 and add 24 to both sides. What do you have? A plus 24 equals d. So they represent the same thing. Just depends on how you looked at that. All right, I'm going to give you about 1 more minute to finish that up.
Quantity of d minus 6, and Amelia is...
Okay, well, hold on. Before you go on, sorry. I noticed a couple of people had this for their past future equation. So my question to you is it okay to have what I just wrote down, that part right there, is it okay to have that instead of the other one?
Yes.
Sure it is. If you multiply both sides by 2, in that one, you have exactly the same thing. There's always more than one way of looking at something. So sorry, Autumn, go ahead.
So Amelia is 30 and her dad is 50.
Okay, and that is what most people got for that one. Same thing as every single problem. I'm using substitution because I think in this kind of problem it's a little easier. I'm going to combine like terms, use a distributive property, and then of course, even though there's only one fraction in there, I still don't want to have to deal with it if I have a choice, and I do have a choice. And so that is a lot easier situation to deal with than the equation right up above. And when I solve that for d, I get d equals 54. So her father or her dad is 54, and that makes her 30 years old. All right, one problem left. Let's take a look at number 6. Number 6 says, next year, Larry will be twice as old as Sean will be. 4 years ago, he was 3 times as old as Sean was. How old is each now? Well, I'm going to use L and S. Anybody want to take a shot at the now equation? Next year, Larry will be twice as old as Sean.
L plus 1 is equal to 2 times S plus 1.
2 times the quantity?
The quantity of that.
Okay, there we go. So next year is 1 year from now. Larry will be twice as old as Sean, so we need to multiply Sean's age by 2 to make them equal to each other. Now, past or future equation. 4 years ago, he was 3 times as old as Sean was. What would that look like?
L equals 3S.
Well, that's what it would be if we were talking about right now, but not 4 years ago, right? 4 years ago, he was 3 times as old as Sean was.
L minus 4 equals 3 times the quantity S minus 4.
There we go. All right, take it over and finish it from there. Most of you got the same answer, so I'm pretty sure that that is correct. I'm going to, first of all, use the distributive property on both of them. And then from there, I'm solving the first equation for L so that I can then use the substitution method. And when I solve for S, I get S equals 9. So that means Sean is 9. And then Larry is 19. Now, I started with number 1, showing you how to check to see if you had the right answer. I'm going to do the same thing with this one. Next year, Larry will be twice as old as Sean. Next year, Sean will be 10. Larry will be 20. That part is good. All right, then 4 years ago, so 4 years ago, Sean was 5 and Larry was 15. It says 4 years ago, he was 3 times as old as Sean. And you can see right there that that has to work. It satisfies both situations that we have there. Any questions about number 6? All right, we are